couple of volunteers who will come up. Okay, how about the two of you in the back? Come on up, and I'm going to grab this chair here, and can you sit in that one right there? And this chair is going to be over here. All right. Excellent. Now, these are just the warm-ups. We're going to get to the stuff that explodes and everything in a minute. Okay, will you hold on to the hairdryer? Okay, and notice I'm just going to tie these together. I'm not even actually plugging them in, but you'll see that I don't need to plug it in for it to work. So I'm just tying that there, and then I have one of those old wired computer mouses, and I'm going to tie that in too. Okay, will you hold that one? Just hold the end of it. No, that, yeah, there you go. So I'm just going to tie this together here. Normally you think of wires, the insulation being a problem, but in this case it's not. All right, now, I should be all set up to go. I need to get you all positioned right, so I'm going to slide you back just a little bit. And would you point that hairdryer up kind of at that light right there? Excellent. All right, and I want you to double check. All right, yeah, like that. Okay, I want you to point that end of it sort of back up at that same light right up there. Okay, excellent. Okay, and I've got the mouse. And the other piece of it, let me check the switch on this. Slide that all the way to the top. There we go. Okay. Now, right in this bottle, I have some soy sauce and some mustard from a Chinese restaurant. And they're floating in this bottle. Okay? And what I'm going to do here is I'm going to show you that, see, I'll stand in the middle so you all can see, that this, wait a second. Let's get that. Yeah, there we go. Okay. Okay. All right, now with your left hand, once I get it down to the bottom here, go ahead and cover where the air comes out of the hairdryer. Okay. Okay, now uncover it. Okay, so let's just see for a second. Keep them both pointed there. You know, keep it there. Now you turn your switch off and turn it back on. Okay, so this is kind of a mystery, right? Right. Another thing that's like science, but it looks like magic. Like, what could possibly be going on? So what are some of the options? What's the science that underlies this? Yeah.
The light could be like producing electricity.
Light, that's a great idea, right? Because we know that like in solar panels, light produces electricity. We can get a force out of that somehow. So what else?
Like the electrical current, where like everything's attached, it's like you tie everything up, so it's like all.
Yeah, so somehow, even though this has insulation on the surface, somehow there's an electrical current. Okay, let me have you all go sit down. Give them a hand for a second. They've done their job. Don't worry, I'm not done explaining this. Here's the thing. A lot of times, people will show you stuff on the internet, and something will look like it's happening, like cell phones are making popcorn pop or something like that, right? And it really looks true. But you're not paying attention to some key element. So look at my hand carefully, okay? And then just notice what's going on. So why were you thinking that it had to do with why were you thinking that it had to do with all that other stuff? The hairdryer? Yeah. I'm tying it up, and oh yeah, and I've got to get it just right. You notice, and when you see stuff on the internet where people are trying to trick you, they are often going to do that, right? We got to do this, we got to get this. Notice I checked the switches, and then did you notice how at first I was like, oh, it didn't work, and then I got him to reposition it? Like, that's all part of getting you to think something. And now, I want to suggest something though. You're seeing the magnetism, right? But have you been noticing my voice? Okay, I'm going to do it more extreme, okay? Just notice that you can change your voice. We're going to talk about sound in a little bit. And then you can have a much lower pitch sound and a higher pitch sound. Now, I was changing my voice before, but not as extreme as I'm changing it now. And so you'll see that, in fact, now why did you think my ring has nothing to do with it, right? So why is it that you thought that my ring was the thing? After that, you were so sure it was my ring. Oh, yeah, it's his ring. It's definitely his ring. Yes, yes, yes. And before I take your question there, what I'd like to do is have you all make a nice high-pitched sound. Ready? Keep going, keep going, keep going. Low-pitched sound over here. Okay, now you can see that we tested it out and we can see how it's working. What I've always wanted to be able to do, though, I thought it would be really cool if I were able to just, like, without speaking at all, if I were to come up with some way where I could just, like, look at it and just go, like. Some things aren't possible. You know, it's like I just have this idea that maybe you'll come to college here and you'll be in my class and I'll finally have figured out a way where I can just, like, you know. Come on up here. Okay. Now, I've been squeezing the bottle the whole time. Go ahead and give it a squeeze so you can show people how that works.
So, it's just the pressure change.
Now that's great. Pressure change, but why does the pressure change make that one sink?
I've done this before with like a paper clip and stuff, but I got no idea.
Okay, well, that is the first place to start in science. I've got no idea. Why do things float and sink? What makes them float and sink? Wait, yeah, in the back. Density. What does density mean? Somebody give me, that's just a word. Somebody give me like a way of thinking about it. What is it? Wait a minute, the weight, but like, hang on a second. I just want to play, I like your idea with the air, but let me play out this idea of weight. People, a lot of little kids will say, light things float. And I'm like, yeah, like boats? You know, like boats are really, like a big battleship is really heavy and a pebble is really, really light, but a pebble sinks and a battleship floats. So it can't just be weight. You said something about air. Somebody said the word density. What do you got? So it's a relationship of volume to weight. Now, here's the thing. This thing is sinking, which must mean I've changed the relationship of volume and weight. In fact, density is how packed together the material is in it. It's another way of thinking it. So how could I possibly pack together the stuff in there? Why does squeezing it pack it together? Yeah.
Buoyancy.
Okay, buoyancy is another word. What does that mean?
It's like, it's again with your analogy of the battleship. It's the air inside of the container.
Okay. Come up here for a second. I want you to see if you can see a little bubble in the top of the packet. It's kind of hard to see in there, right? Now, when I squeeze this, what do you think happens to the bubble?
It shrinks.
It shrinks. It's like I've made this thing more dense temporarily. The bubble has gotten packed closer together. When I let go, the bubble expands, right? Stay where you are, and I want to just show you something, okay? Hold on to that. Okay. If I press here, what's going to happen here?
It's going to go up.
Okay, it's going to go up, right? Now, I want you to press there, but I'm not going to let it change volume. Right? Now we've packed the air tighter together. As soon as I let go, it expands. So what's going on, give my friend a hand, thanks. I can temporarily compress that air. As soon as I let go, the air is going to expand. I think of it like air molecules don't, quote unquote, like being close together. I have to push on them to get them close together. As soon as I get them able to move apart, I'm not pushing anymore, they spread apart and that thing floats. Okay, so that's another great example, and it brings me to this, which I think is really interesting, because normally I don't think of things floating in the middle. So you said that things tend to float if they are less dense or more dense. We didn't really nail that down.
I think this probably, I'm thinking of those are able to float, but there's something dragging them down.
Okay, that's a great thought. But let's go back. Hang on to that. Let's go back. What if the things sink or float? If they're more dense or less dense, how would you say that? Explain to me why they sink or float related to the density. Yeah.
Density of the liquid is either less dense or more dense than the object, or the same density, so that means it sinks or floats.
I like it. So if the density of the liquid is more dense than the object will float. If the object is more dense than the liquid, the object will sink. That's great. So in this case, you're like, maybe it's the same somehow. So what do you think is going to happen if I flip them over?
It's gonna stay.
It's gonna go down.
Okay, do you think the blue and the white are gonna, well, let's find out. So in science, one of the great things you can do is you kind of like, I'm not really sure, I have a guess, but let's see what happens. Huh.
What?
So why is the blue always on the bottom? Based on your ideas about density, why is the blue always on the bottom? Yes, sir. The air is on the top. That must mean it's the least dense thing in there. You're right on about that. But what about these two things? Yeah.
Maybe because the blue is more dense than the white, but the white is still more dense than the water.
Oh, so wait a minute. The white is more dense than this liquid, but the blue is even more dense than the white. How about this?
That's the most dense.
Now, wait a minute. There might be two different liquids. I get so excited when somebody comes up with this, just by thinking about it, that I just kind of go wild. And when I go wild, something new happens. I've broken it.
You've
It's
mixed
like
the two
bubbles.
liquids.
I've mixed the two liquids, and you can actually, yeah, it actually doesn't transmit light as well when they're mixed. And notice how they're coming unmixed as they, see, I can do the same thing, and they'll be, the white will still be on the top. Least dense is the air, more dense, more dense, more dense, the mixture, then the blue, and then the most dense is here. What liquids would I use for something like this? What do you think? What would be two good liquids? They have to mix only temporarily, right? Sir? Water and vinegar, water and vinegar will probably mix pretty well. Right? You can water down vinegar. In fact, vinegar is acetic acid that has been watered down already. So but you're onto something. What do you think? Water and oil. That would work in this. The problem is that the water and oil you'd see it. It would be like little globules like in salad dressing. Yeah.
Sparkling water?
Ooh, sparkling water. It's interesting, although we'd see the bubbles in there. In this case, it is actually salt water and rubbing alcohol. Now, the thing about salt water, if you've got a fully saturated saltwater solution, is the salt, the NaCl, protects the ends of the water molecules so they can't dissolve the alcohol. And so the alcohol gets mixed in temporarily, but it can't stay dissolved. Normally, you can water down rubbing alcohol. But in this case, if we put it with salt water, you can't. Now, I'm not trying to teach you a whole bunch about chemistry of salt right now, but what I want you to see is that as you're looking at something like this, you start with this sense of wonder. You're like, well, wait a minute, how does this thing work? And let's try this. And then we work it out based on things we know, and maybe I tell you a little something. The feeling, like if I had just walked in and said, hey, look at this, and had done that, and I'd said, put it away and gone on, you'd have been like, wait a minute, how does that work? You want to know. Your brains want to know. And this is because you all are the descendants of people who were curious.